Hello friends, so today we're going to discuss this problem number 1448 from the latest Biweekly contest 26. Problem name, count good nodes in a binary tree. So you are given a binary tree like root, and a node x in the tree is called good if in the path from the root to x there are no nodes with a value greater than x. So if you understand the question well, the question statement states that if for every node, like there is no other node which has a value greater than, if we move from the path from that node to the root node. So as you can see, that for a root node the value is always 1. It is also counted, always counted 1, or like to be a good node because it is at the root node. Now if you take this node, the value of this is less than the root node. So if we take a path from this node to the root node, the value of all the nodes should be greater than or equal to the node value of the root. So as you can see, this value is less, so this is not counted. Now because 3, from a path till this node to this node, all the nodes have a value greater than or equal to this value, greater than x. So node x in the tree is good if from the path like this value is greater than or equal to all the values in the path. Okay, so as you can see, this value is greater than or equal to all the values in the path. This value is also greater than or equal to all the values. This is not. This is also greater than or equal to. So as you can see, for every node we just wanted out whether this is the maximum till now. Okay, because if we know that 3 is the maximum in this path, then because we have moved from this to this and 3 is the maximum, then yeah, because it can be considered as a good node. So let me take you to the drawing board and it will be more clear. So now because the root node is always counted as 1, so the count of the good node is 1. Now the maximum is 3 till now. We will send this 3 here and here. Okay, so now what does this signify? It signifies that the value of the above node, for the above node from this to this to all the path, the maximum should be at least 3. So it means that the value of this node is 1, and if its node value is less than this value, then all the values above it will be having this value, and this value has less value, so it cannot be a good node. And we will send the maximum till now to all its children. So the children of this is this. So we will send this value to this, and because it is null, we will send nothing here. Now the 3 is actually greater than or equal to this value. It means that all the values above will be having a value of at most 3, because 3 is the maximum from the root till this path. That's what it signifies. And our root and our node value is also 3. It means that 3 has a value which is greater than or equal to all the values from the path from the root till here. So it is also a good node. It is a good node. And because now same for this, it is a good node. And now the maximum is 4. So we will send 4 and 4 here. And because also 4 is less than 5, it is also considered a good node. Okay. So now let's move on to the code now. The code is also very simple. If the root is actually null, if the root is null, it means that there is no root. So that means that the count should be 0. Okay. But if the root present, it means that the root is always a good node. So we increment our count to 1. Now we do a DFS on the left child and the right child of the root node, and we will make a maximum which is the root value. Okay. Now our DFS will take the root value and the maximum value. Whenever a root encounters null, we just return. Else, if our root value is greater than or equal to the max value, we increment our count, which is global. And then if not, we will just do a DFS on the left child and the right child, sending in the maximum of the maximum till now and the root value, which I've told you. So I've sent the maximum till now and the root value. Because now the root value is more than the maximum, so we send this value. And this is accepted. I hope you understand the logic and the code. If you still have any doubts, please mention down. Thank you for watching this video. keep coding. And if you like my explanation, please hit the like button. I'll see you in the next one. Bye.